Welcome to Session 6 on your way to testing for your Technician Class Amateur Radio license. In this session, I'll be discussing your amateur radio, repeaters and how to use them, and repeater systems. Modern radios, amateur radios in particular, are usually a transceiver. That means it is both a transmitter and a receiver in the same package. In the 1950s and earlier, it was common to have two units, a receiver and a transmitter, each independent of each other, with the method to transfer the antenna connection from the transmitter to the receiver and back. Following is a video description of the characteristics of a very popular Technician handheld radio. This radio is a Baofeng Model UV5R handheld transceiver. It is made in China and, due to its very low price, has become very popular. In reality, it's not a great radio. It may be a good starter radio, but you'll soon want a much more capable radio. However, it does have all of the characteristics of an amateur radio. The push-to-talk switch is on the side. It's in a position to be able to switch from receive to talk while holding the radio close to your mouth and ear. The radio has 175 available memories, as I remember. In memory mode, switching from one memory to another is easily accomplished. I can either cycle up,
2, 1.
No, that was cycle down, cycle
2,
up,
3, 4,
or
5,
down,
4, 3,
or I can just type in the number of the memory I want.
0, 3, 5.
And I've got the Pisgah repeater set up in that particular memory mode. All hand radios have a detachable antenna, which means you can put different antennas on the radio. As we'll discuss in a later video, all antennas are compromise antennas. They're in some fashion. The antenna that usually ships with the cheap radios, like the Baofeng radio, is a very poor antenna and transmits and receives kind of like the antenna is a rubber duck, hence the term for a poor antenna. This radio has one mode of operation, frequency mode.
Channel mode.
A more expensive and capable radio may also have other modes of operation such as single sideband or digital modes. In addition to having memory channels, this radio can also be operated by entering the frequency directly. This is accomplished by switching into VFO mode and entering the frequency on the keypad. 1,
4, 6, 5, 2, 0.
And it's done. Most radios have a squelch circuit to mute the receiver when there is no signal present. It requires a sufficiently strong signal to open the squelch. On this radio, I can set the squelch level. That's a menu item. And it's menu item at the very beginning of the menu thing. And if I press the menu key, I can increase the squelch level required, or I can decrease the squelch level required. I found that on this particular radio, a squelch level of 3 is very adequate. There's also a button on the side, right next to the push-to-talk button. So the push-to-talk button is up here, and right below it is this button that opens the squelch. If I press and hold it, you'll hear anything that's on that. You'll hear anything that's on that frequency, regardless of how weak or how strong the signal is. If sensitive enough to pick it up, you will get it. Finally, this radio has the ability to operate in Simplex mode, that is to transmit and receive on the same frequency, or in split mode, where the radio transmits on a different frequency than the receiver is receiving. This capability is required to be able to use a repeater system, as we'll see later in this video session. Okay, back to the slide presentation. As you've seen, the radio I just showed you has all of the standard characteristics listed on this slide. So what's the difference between this handheld radio and the other more expensive radios? There are two major characteristics of a receiver: its sensitivity, that is, the ability to hear weak signals buried in the static, and its selectivity, the ability to reject strong adjacent signals. This Baofeng radio is just so-so in both selectivity and sensitivity. On the transmitter side, there are also two important characteristics: signal quality and unwanted signal suppression. The signal quality refers to the crispness and clarity of the signal as heard by the human ear. Higher quality components make the difference in signal quality. All radio transmitters generate a signal on the desired frequency, but they also generate signals on the harmonics or multiples of the frequency. The FCC requires a minimum of 35 dB suppression of harmonics, and we'll discuss what decibels mean and how to use them in a future video. About half of the Baofeng radios fail the harmonic suppression test. Lastly, more capable radios have the ability to operate in multiple modes, particularly digital modes. They may also have a GPS capability. For instance, one of my handheld radios can be grouped together with other radios, and my handheld will display the relative location of other group members from where I am. It's very useful in the backcountry. It's also possible to spend $500 or more on a very capable radio. Most handheld radios will have a maximum power output of between 4 to 8 watts. Mobile units will be in the 50 to 75 watt range. Desktop stations can go up to about 100 watts. To get even more power, an amplifier is required. As an aside, before spending money on an amplifier, because they're pretty expensive, spend money on the antenna. When you're gone as far as you can to improve the antenna performance, then consider an amplifier. Note that some bands and some license classes have restrictions on the power output of a radio or amplifier. In most cases, 1,500 watts is allowed, but there are bands where techs are limited to 200 watts. Repeaters make up the backbone and the heart of the technician class world. Operating Simplex, that is, transmitting and receiving on the same frequency with a 5-watt handheld radio, will give you a range of about 10 miles with no obstructions like hills or tall buildings in the way. Higher power will get longer distances with a maximum distance on flat ground of about 75 miles. While the Earth is curved, VHF and UHF radio waves travel in straight lines, and so they just go off out into the ether forever. These limitations have led to the invention of amateur radio repeaters. The repeater listens on one frequency and simultaneously transmits on another nearby frequency. Repeaters are usually put up very high, on mountaintops or on tops of tall buildings or high towers, which gives them much more range before the Earth curves away from the signal. Around the world, repeaters have pretty much standardized on the split between the frequency the repeater is listening on and the frequency it is transmitting on. On the 2-meter band, the split is pretty standard at 600 kilohertz or 0.6 megahertz. On the 70-centimeter band, the standard split is 5 megahertz. The split can be either positive or negative. Local conventions dictate the split direction. In Utah, on 2 meters, a negative offset is used for 147.00 megahertz and below, while a positive offset is used for those above 147.000 megahertz. In Utah, all 70-centimeter repeaters use a negative offset. In the early days of installing radios in taxicabs, Motorola was the dominant supplier. Cab companies were very concerned about another company overhearing a dispatch and stealing the customer. The customer ordered a cab, and he doesn't care who shows up as long as it's a cab. To prevent this, Motorola invented this private line code, or PL code. This code was programmed into the cab company's transmitter and the cabbie's radio. The code is a subaudible tone. That's a tone that the human ear can't hear, that would cause the receiver to open the squelch if the tone was present. If a transmission was received that didn't have the proper subaudible tone, you wouldn't hear it. That way cabbies could not hear each other's traffic. Private line code, or PL code, is a trademark owned by Motorola. The full name of this capability is Continuous Tone Quoted Squelch System, or CTCSS. Many repeaters utilize this method of suppressing unwanted transmissions. Anything heard on the input frequency would need to be encoded with the subaudible tone in order to be transmitted on the output frequency. But since repeaters require the use of two frequencies, an input frequency and a transmit frequency, 600 kilohertz apart on 2 meters or 5 megahertz apart on 70 centimeters, local volunteers work with the local amateur radio community to coordinate the frequency pairs. Please note that the FCC is never involved in repeater coordination. They only get involved when there is deliberate interference. For your information, there are no unoccupied repeater frequencies in Utah on the 2-meter band. There are a few open frequencies in the 70 centimeter band and quite a few in the 1.25 meter band. The Utah VHF Society, their website is at utahvhfs.org, does all of the repeater coordination in Utah. You can put up an uncoordinated repeater. However, if you cause interference with another repeater that is coordinated, you can be held liable. Since repeaters listen on one frequency and transmit on another frequency, it is fairly easy to determine if you can have a conversation with somebody on a simplex rather than over the repeater. Just listen on the repeater's input frequency. If you can hear the person, you can connect without a repeater. You'd be surprised how well simplex communications really work. Audio volume and audio quality are often an issue with handheld radios, particularly the more inexpensive ones. Speaking too loudly into the microphone will cause the signal to over-deviate, which causes splatter and dropouts on your signal. Speaking too softly may cause your voice not to be transmitted. You just get a carrier and all everybody hears is silence. It's a good idea to talk with someone on the simplex frequency to get a good signal report and learn how close to the microphone your mouth should be. To use a repeater, you need to know 3 things and then set up your radio accordingly. You need to know the repeater's output frequency. That will be your receive frequency. You need to know the repeater's input frequency. That would be your transmit frequency. Some radios require you to enter both the transmit and the receive frequencies. Most radios, however, require you to enter the receive frequency and the offset direction. The radio adds or subtracts, as the case may be, the offset from the receive frequency to determine the transmit frequency. If your radio calculates the transmit frequency, then you'll need to know the offset direction plus or minus and the offset amount if it's not standard. Finally, you need to know if the repeater requires a CTCSS tone. If so, this tone needs to be on your transmitted signal. You're driving down the highway and see this sign. Everything you need to know to use the repeater is on that sign. The transmit frequency is 145.33 megahertz with a standard negative offset. The CTCSS tone is 131.8 hertz. To use this repeater, I set my receive frequency to 145.33 megahertz. If the radio uses the offset, then I set the offset to 0.6 megahertz and the shift direction to negative. If the radio requires me to enter both the receiver and transmit frequencies, then I would set the receive frequency to 145.330 megahertz and the transmit frequency to 144.730 megahertz. 6 kilohertz below the receive frequency. Then I would set a tone of 131.8 hertz on the transmit frequency. So here's how I do this on my Baofeng UV5R radio. If I'm going to program my Baofeng radio for that particular repeater, this is how I would do it.
Frequency mode.
I turn the radio on, and I make sure that I'm in frequency mode.
Frequency mode.
Frequency mode. Then, get it so you can see the screen, I'll type in the frequency that I want to receive on, which is 145.330.
1, 4, 5, 3, 3, 0.
And press the menu button to confirm. And now I need to set the offset. So I go through the menu items until I find something that says offset. Obviously there are a lot of them, and I get there.
Offset frequency.
I press the menu button so I can set it. Type in 0, 0, 0,
0,
6, 0,
0,
0,
0.
and the menu button to confirm it. Now I need to set the shift direction, and I saw that when we come up, it's one menu back. So I press the menu button, press the arrow buttons until I get the offset direction I want, press the menu button to confirm. And now I need to set the transmit CTCSS tone. So I keep going through the menu items until I find that guy. There he was. Transmit CTCSS. I press the menu button and then find, go up. There are a couple hundred of these. I find 131.8. There it is. Okay. Press the menu button to confirm, then press exit. And now I'm set up to be able to use that repeater. When I transmit, I'll be transmitting a 144.730, and when I receive, I'll be receiving a 145.300, and when I transmit, I'll be sending a CTCS tone with it of 131.8. Now there are also menu options that I can use to store what I just programmed into one of the memory channels. If this were a repeater that I would use often, I would do that so I wouldn't have to set up the repeater every time I wanted to use it. Okay, back to the slide presentation. If you're having trouble with a repeater, check the items listed on this slide. There are a couple of repeaters along the Wasatch Front that use digital coded squelch rather than a CTCSS tone. Quite often, if someone is having trouble hearing you on a repeater when you're using your handheld radio, simply move a few feet and the problem will likely go away. There are a number of repeater systems in Utah as well as across the country. Essentially, these are a set of repeaters that are all linked together. Whatever is heard on one repeater is simultaneously transmitted on all repeaters in the system. In Utah, the most popular repeater system is the InterMountain Intertie. I'll talk a little bit more about that on the next slide. Down in the Moab area is a repeater system called the Sinbad system, which is very popular and useful for off-roading and backcountry enthusiasts. There's a linked repeater system all down the coast of California and along Interstate 10 through Arizona, and there are many, many more across the country. Are you looking for information about repeaters or repeater systems? There are repeater directories published as books. They're also available online and available as an app on your smartphone. Most repeater coordinator clubs publish their information on the internet as a web page. For instance, if you're going to Idaho, do a search for amateur radio repeaters in Idaho, and a very nice web page will be available. Note that if you transmit something into a repeater that violates FCC rules, you, as the control operator of the originating station, can be held liable. If you transmit into a repeater, identify yourself. It is very annoying to be monitoring a repeater and have someone chunk the repeater a number of times with no identification. Just don't do that. The InterMountain intertie is an incredibly useful repeater system. I use it all the time when I'm traveling. It's not uncommon to be driving down I-15, say in the Cedar City area, and have a conversation with someone in West Yellowstone or Flagstaff or Boise. The intertie is a popular and very active repeater system. It consists of linked repeater systems from Billings, Montana in the north, Boise, Idaho in the northwest, Flagstaff, Arizona in the south, and Las Vegas, Nevada in the southwest. Repeaters and repeater maintenance costs money. After you're licensed, consider joining the Utah VHF Society for $20 a year and help support this beneficial and useful repeater system. This concludes session number 6. I've discussed the characteristics of your amateur radio, repeaters and how to use them, and repeater systems. Jot down any questions or concerns so that we might discuss them in the online class, or you can email them to me at rolandksmith@gmail.com. We'll see you in the class.